A very good morning to one and all. Today's session is level and methods to calculate the level. So to start with, this is a simple dumpy level that is shown in the picture used for leveling. So we could see the parts of the level now. It consists of an object's focus screw, horizontal circle, tri-barge, foot screws, trivet and leveling head. So this is the level instrument and this is how it actually looks. Next is the staff. The leveling staff is kept at the station point for recording the elevation of that point. So this is the position of this leveling staff will be considered for leveling. There are two types of staff: self-reading staff, target staff. In self-reading staff we have solid staff and folding staff. The least count of the leveling staff is 0.0005 and it is graduated in such a way that we can record the elevation up to 0.005. What are the parts of the dumpy level? We have an eyepiece, a diaphragm, a focusing screw, a longitudinal bubble, a cross bubble, shade, object glass, circular compass, tri-barge, foot screws, leveling head and tripod stand. What are the temporary adjustments of the level? First, we should select a suitable position. Then, fixing the level with the tripod stand. Next, approximate leveling by the legs of the tripod stand. After that, perfect leveling of the foot screws. Then, focusing the eyepiece and object glass. And finally, taking the staff readings. How to level the level? Leveling is done to the leveling equipment by keeping the telescope parallel to any two foot screws, that is the first foot screw and the second foot screw, and adjusting the leveling screws till the bubble comes to center. And the next step is keeping it perpendicular to the third foot screw and adjusting the leveling screws till the bubble comes to the center. So this is how leveling is done to the level. What are the sources of error in leveling? We have instrumental error, personal error and error due to natural causes. What are the methods of leveling? There are two methods for obtaining the elevation of points. One is height of instrument method or height of collimation method or plane of collimation method, and second method is rise and fall method. Height of instrument method. The basic equations are: the height of instrument for the first setting is equal to the reduced level of the benchmark and the backside. Subtract the intermediate side and foresight from the height of instrument to get the reduced level of the intermediate stations and change points. The check is done as summation of backside minus summation of foresight is equal to last RL minus first RL. This is negative in case of fall and positive in case of rise. Next is the rise and fall method. In this method, the difference of the present staff reading is subtracted from the previous staff reading. Previous reading and present staff reading is equal to positive, it denotes rise, and if it's negative, it denotes fall. Checking is done as summation of backside minus summation of foresight is equal to last RL minus first RL, that is equal to summation of rise minus summation of fall. Here, let us see an example of the following staff readings were observed successively with the level of instrument moved by the third, sixth, and 8th readings: 2.228, 1.0606, 0.988, 2.090, 2.864, 1.262, 0.602, 1.982, 1.004 and 2.684. Enter the reading in the record book and calculate the reduced level if the first reading taken at the benchmark is 432.383 meters. Now let us see how to calculate it in the first method, height of instrument method. As we all know, the instrument is shifted after the position of the third and fifth points and it is recorded. At third and fifth points, the instrument position is same. So the foresight and backsight readings are recorded at the third, fifth positions. The last reading is denoted as the foresight, and the first reading is recorded as the backsight. Remaining intermediate points are written on the intermediate sides. The table is shown as follows: station points, backsight, intermediate side, foresight, height of instrument, reduced level remarks. So therefore, the height reduced level is calculated as a reduced level given in the question is 432.384. That is added with the backside. It is for the getting the height of instrument. So that is added with intermediate side of foresight to get the reduced level, and again that is added to backside to get the height of instrument, and that is again added to intermediate side of foresight to get the reduced level. In a similar way, all the readings are calculated and the change points are located, and the check is done. Summation of backside minus summation of foresight should be equal to last RL minus first RL. That is shown as minus 0.952. Let us see the similar case in rise and fall method. The same tabular column. The recording is subtracting it with the reading. Here, if it is positive, it is rise, and if it's negative, it is fall. The reduced level is calculated by adding it to the rise and subtracting it to the fall. Here, the check is recorded as summation of backside minus summation of foresight is equal to last RL minus first RL. That should be equal to summation of rise minus summation of fall. Here, in all cases, it is minus 0.952. So, this is how we determine the level by using rise and fall method and height of instrument method. Next is curvature and refraction. Curvature and refraction are two important things that should be considered in leveling. Let us see that one by one. Curvature correction. Curvature correction will be always negative. A properly adjusted instrument takes the reading with respect to horizontal line. So something has to be subtracted from the staff reading to get actual reading. So that is C suffix C is equal to D square by 2R, where D is the distance of the staff from the point of tangent C, and R is the radius of the earth. Therefore, CC is equal to minus 7.849 into 10 power minus 8 into D square meters. Effect of refraction. Air is denser near the earth and becomes thinner as we go away from the surface of the earth. This causes refraction. CR is equal to 1 by 7 into D square by 2R. The combined effect CC plus CR is equal to minus 6.728 into 10 power 8 into D square. So this is the error due to curvature and refraction, and it is important that we should consider this. So thank you all for your attention. Hope you have understood today's class. If you have any queries, kindly post it. Thank you one and all.